At this point, I want to go over the complex root theorem. This is another theorem. So this just says if you have a root at a plus bi, I being an imaginary number, then a minus bi is also a root. That's because imaginary numbers come in pairs. For instance, if to get a root of just I, that means we would have had a factor of x squared plus 1. Now remember, to find your roots or zeros, you set that equal to 0. So you get x squared equals -1. Well, when you take the square root of both sides, you need to remember that you have a positive and negative answer. Okay, so imaginary numbers always come in pairs because you have a positive and negative value for it. So that means the same thing could be said for roots with square roots. So a, or actually any even root really. So anytime you have a root of a plus square root of b, you also have a root of a minus square root of b. Now this is helpful because sometimes a problem might give you a list of zeros or roots. Based on that list, you can sometimes automatically find other zeros or roots because of that theorem. So for instance, on this one, 2 plus square root of 7, because we have that square root, and it's a positive square root, we know we have another 0 or root at 2 minus square root of 7. Same thing can be said for this imaginary value, 3i. Because it's imaginary, we know automatically that there should also be another root at -3i. Now, we don't know anything about -9, so it's only if there's a square root or any of those even roots and then imaginary numbers that this is true. And that's about all for the complex root theorem.